This video, we're going to go through the entire lesson. So it'll be a little bit more of a lengthy video, but this way, in case you missed it or in case you struggled on it or something, you can kind of go back through everything. This one we're dealing with functions, specifically inverse functions. So we're going to learn how to calculate the inverse of a function. I use this one a lot whenever I receive bills that I really don't understand how much they're thinking it should be. I use this whenever I talk to Bank of America when they overcharge me for things. Okay, so is this one a function? If we were to draw a vertical line straight up and down, this one would indeed be a function. We draw a line straight up and down there, it only intersects once. Over here, it only intersects once. Now we're getting on something called a one-to-one function. In order for it to be a one-to-one function, number one, it's got to be a function here, as well as if we drew the lines straight across horizontally. Then it would also be a one-to-one function. So yes, this one is a one-to-one function. Let's take a look at another one here. This one here is a function. If you draw a line straight up and down here, it only intersects once. That one is a function. However, if we draw a line side to side, it intersects more than once, so this one is not a one-to-one function. So it does not pass the vertical and horizontal line test. That's what we consider a one-to-one function. And in order to find an inverse of something, then it's got to be a one-to-one function. So that's where it's going to become important. But I want you to try both of these, so go ahead and push pause on the video now. Write down whether it is or is not a function, and then come back and push play. Check your answer here. Number one was not a function. If we drew a horizontal line, it does not pass that. Number two does pass the vertical and horizontal line tests. So this one, number two, is considered a one-to-one function. All right, and a real life example of this is a lot of times that we might find some information one way, but we really need the reverse. Say you have you're attending high school and you want to go to college as well, and you know that you've got, say, 7 extra hours each week that you can devote to something, and you want to see if you can maybe take a class at the college. But the college will publish something that says, okay, if you take 3 credits, expect to spend 5 additional hours each week studying. If you 4 credits, that's 7 hours. Well, an easier way to do this, and this is kind of an oversimplified example, but an easier way to do this one is if you could somehow find the inverse of that. Then you go, okay, here I am. I have 7 hours available. That means I can take up to 4 credit hours. Okay, so that's kind of what we're going to be starting to use these inverses on. Nothing quite this simple. We're going to get a little bit more complex with that. But it's basically kind of taking it the other way and looking at it from a different vantage point. Instead of worrying about the number of credits you take, you need to devote this many hours. You can say, hey, I have this many hours available. Here's how many credits I can take. Kind of the opposite if you want to think of it that way. One important thing that we need to note here, let me go back here, is if you look here, in order to be inverses, whoops, I made a mistake there. Sorry, I keep doing that. Okay, here we go. So the input on this one becomes the output on the inverse. Okay, 4 is the input here. If we look at the inverse, 4 is now the output. 7 was the output here, and now that's the input. So we basically are switching all of these inputs and outputs. They're basically changing places. That's the inverse of a function. All right, so let's look at these two. These two, believe it or not, are inverses of one another. So we're going to go through this, and we're going to pick any number, and it doesn't really matter what number we pick. I chose 8 just because that's a nice even cube root. Cube root of 8, so I'm going to plug 8 in here for x. So if x were to equal 8, the cube root of 8 is 2. 2 plus 1 is 3. Okay, so we've got this 3. So if my input is 8, my output is 3. Now, if this one is really my inverse, I ought to be able to take my output and switch it. So this becomes my input on the second one. So I'll do that now. The 3 becomes my input. 3 minus 1 cubed. 3 minus 1 cubed, let's see, 3 minus 1 is 2. 2 cubed is 8. Well, if we look here, this becomes extremely important. My input on one was 8, that becomes my output on the other. My output on the first one becomes my input on the second one. That's what denotes that these two are actually inverses. Let's look at another example. It doesn't really matter what number we plug in here, negative 27. I'm going to use that for my input on f of x here. So I go negative 20, the cube root of negative 27 plus 1. Well, the cube root of negative 27 is negative 3. Negative 3 plus 1 is negative 2. Okay, so for an input of negative 27, my output is negative 2. Well, if this one here is my inverse, then I ought to be able to switch these two. This should be able to become the input, and that would be my output. So let's try that. The input of -2 here, I'm plugging that into this one. -2 minus 1 is -3. Cubed is -27. So that worked as well. So again, if I were to write this one, here's my function notation. This is my function. This is the inverse. This little -1 here, that is not an exponent. This is a function notation that tells us that this particular one is the inverse equation, inverse function of this one right here. Okay, so now let's look here. We've got an 8. This would be my x value, my y value in this case. This is my output. That would be my 3. Well, if it's indeed the function, these two should switch sides. Okay, so this, the 3, instead of being my y value, should now be my x value, and indeed it is. That's my x value. My 8 becomes my y value. Same thing on the one down here. We're basically just switching spots. This was -27 was my input, -2 was my output. Then I plugged it in the second equation, and those were my, they flipped sides. So these two are inverses. So the big thing is, we haven't really shown you yet how to calculate an inverse. This particular portion right here will not be on your homework. It's just more for an explanation. The important thing with an input, with inverses, are that the inputs become the outputs, and the outputs become the inputs. They basically switch spots. All right, and that's a good way you can kind of check your answer as well to see if it's indeed, if you obtain the correct answer. All right, so if we're wanting to find the inverse here, all right, the very first thing that we're going to do is we're going to kind of change it back from this function notation to what we're used to. We're used to seeing it as a y equals. So now we've got it as y equals 4x minus 3. Well, the whole process of an inverse is that the inputs and outputs switch spots. So if that's true, then I ought to switch this x and this y around. So I do that now. I switch the x's and the y's, then I'm going to solve it for y. Okay, right now it's solved for y. So in order to find the inverse of this, I switch these two around and then solve it for y. So I switch the two around. Notice how my 4 still line up, my -3 still line up. All I basically did is I put this y where the x was and the x where the y was. Because that's the whole premise of an inverse, is that we can switch the two. All right, now we're going to solve this one for y, and that will tell us what our inverse is. Okay, so let's solve it for y. In order to solve it for y, I need to get this -3 over to the other side, so that means I'm going to add 3 to both sides. Then I end up with an x plus 3 equals 4y. I need to get y all by itself, so I'm going to divide both sides by 4. So then I end up with a y equals x plus 3 divided by 4. So this is my inverse. Now, the way that we'll do this one is we'll write it in function notation. So here is my original function, 4x minus 3. That's where I got this one. The inverse of this one, remember we're going to write that with the little -1. The inverse of that one is f of -1 of x. X plus 3 over 4. Okay, that's my inverse on that one. Now, and if we wanted to, we could plug in any sort of number that we wanted here. If we wanted to plug in a 1, 4 times 1 is 4, minus 3 is 1. So if we plug in 1, and well, 1 and 1 is, that doesn't really help much. Let's plug in a 2. 4 times 2 is 8, minus 3 is 5. So if the input is 2, the output is 5. That means we should be able to switch that. If this is 5, 5 plus 3 is 8, divided by 4 is 2. So you'll notice that those inputs and outputs switch spots. We did get the right answer there, so we're okay. All right. The graphs here, they basically switch spots. The x values and the y values just basically switch spots. It's kind of very interesting the way that works. Let's go through this one again. I'll do one more example here. First thing that we have to do here is we switch this from function notation back to our traditional one, which is our y value. Then we're going to switch the x's and the y's. So we write down that one. Now we're going to switch our x's and y's around. Again, they just trade spots right here. That's it. Now we need to solve this one for y. I need to get y all by itself. This 2, I need to get rid of that. So I'm going to subtract 2 from both sides. And that'll give me an x minus 2 is equal to y cubed. Now we have to ask, how can I get rid of this cube? Because I want just y. I don't want y cubed. Well, the opposite of y cubed is going to be the cube root. So we take the cube root of both sides. This cube root and this cube will cancel each other. That will just leave me with y. Y equals the cube root of x minus 2. Notice all of this is in the cube root. Because from here, I cube rooted this side. That means I have to cube root this entire left side, which is what I did. So we have our original function here. This is the one that I had up top here. Then the inverse function will be noted with this -1 here, is this one right here that we just obtained. Okay. So you'll look for those, how you want to write it on the test. We write it as this f inverse of x equals, and this is the cube root of x minus 2. All right, so let's give you a chance to kind of practice this a little bit. I'd like you to try both of these two. Try this. Now, remember, the first step is to write this as a y equals x plus 7, then switch the x's and y's and solve it for y. So go ahead and try both of these right now. Push pause. After you've obtained your answer, come back and push play. Check your answers here. This first one really wasn't too bad. We just had to move the 7 over, and that was pretty much it. This second one's real similar to the second one that we just did. Instead of taking the cube root, though, you're going to take the 5th root is really the only big difference there. So let's try another one. We're going to use the same process all along here. I want you to try both of these. I'm going to have you find the inverses of both of these. Both of these added a whole new level here. We've got a 3 here. You've got to know what to do with that one. And this one over here, we've got a negative here that we're going to have to worry about as well. So on this particular one, I will give you a hint. If you want to solve this one, you want to multiply both sides by 3 first. All right, go ahead and push pause now. Try to obtain both answers. Come back and check your answers by pushing play. Check your answers here. Notice here you have to multiply both sides by 3 first. I did mention that. Then it's just a really common equation that we've got here, and that one, it really isn't too bad. When we get to it over here, when you take what I did on this one, there's a couple different avenues you can take on it. So if you didn't take this one but you obtained the correct answer, you're probably okay. On this particular one, I ended up dividing by -1 to both sides, so that's how I got this. But you didn't have to. You could do it a little bit differently if you wanted to, but that's the way that I chose on this one. So you could have had a negative. Let's see. You could have done it a couple different ways, but this is the one that I find to be the easiest route. Okay, let's have you try. Let's have you try this one. This is a real life scenario. Okay, you own the Dairy Queen. The royalties that you have to pay Dairy Queen are represented by this function. X is the gross sales for each month. So you got to pay them $500 plus 6% of the sales. That's how they earn their money. Dairy Queen does. Okay, so what we want to do now, we have to find 2,000, f of 2,000, and interpret its practical meaning. Okay, so you've got to know what this 2,000 means, and then actually how to calculate it. So push pause now. I would like you to find f of 2,000. After you've obtained your answer, come back and push play. But I want to know what the number is and what that number represents. Check your answer here. Hopefully you obtained 620. There we go. 620. 620 was your amount. That's what you had to pay in royalties. That means if you sell $2,000 worth of good, because this is our X value. X represents the gross sales for each month. If you sell $2,000 worth of goods, you have to pay $620 to Dairy Queen in the form of royalties. So now what we want to do is we're going to take the same scenario. This time what we're going to do is calculate what the inverse is, because sometimes you'll receive a bill from Dairy Queen and they'll say, okay, you need to pay this amount in royalties. You want to make sure that they're calculating the amount, your gross amount, whatever your sales were, correctly. So it's easier just to calculate what the inverse is of this function, then you'll have that, and you can use that every single month. Whenever the bill comes in, you can say, no, you're calculating this based on us selling this amount. Really, we only sold this amount. Okay, but I want you to go ahead and try that. So calculate what the inverse of this one is. Right now, push pause. After you've obtained your answer, come back and push play. Check your answer here. This should have been your inverse, x minus 500, all divided by 0.06. That's f1 of x, okay? All right, so we're going to try just a couple more. These will not be the real life ones. These will just be the traditional ones. I'd like you to try both of these. Push pause now. After you've obtained your answers, come back and push play. Check your answers. Okay, this one isn't so bad, especially if you can understand that the raised to the 5th power, the 5th root will cancel that one out. It's really not that bad. This one can be really confusing, number 2, so this might be one that would be worth putting into your notes. This one, in order to do this one, what we're actually going to have to do, notice how we did our y equals first, then we switched our x and y's. Well, I'm trying to solve this one for y, so the only way to do that is to multiply both sides by whatever this denominator is. That gets rid of our fraction for us. So by the time that we did that here, you can see that left us with negative y minus 2 times x equals 2. Now again, we're trying to get y all by itself, so in order to do that, I'm just going to divide both sides by x here. That's where I got this 2 divided by x, okay? So again, I multiplied both sides by this negative y minus 2, whatever the denominator was. Then I ended up with negative y minus 2 times x, that quantity times x equals 2. Well, I'm trying to get y all by itself, so I'm going to divide both sides by x. Okay, then it's not too bad. Then you can move your 2 over and then divide by negative 1. This one is fairly complex. If you can do this one, you're doing really well. The next one I'm going to give you is very complex as well. So if you can get these, you're starting to really kind of get it. These are going to take a lot of practice. This is not an easy lesson. This is one of the more difficult ones that we'll cover. All right. So these are the last two. I'd like you to try both of these. After you've obtained your answers, come back and push play. Now you'll notice on number 1, this is really similar to the last one that we just did. So if you need to, I'll go back and rewind the video just a little bit and see how we did that one. All right, go ahead and push pause now. After you've obtained your answer, come back and push play. Check your answers here. Okay, so we had quite a bit going on here. This one was real similar. The only thing that was really different is that we had to move this 2 over first. Okay, so this became, and notice I use an n here. Whether it's an n or an x, it really doesn't matter. We're still switching the two variables around. But then by the time we multiply both sides here by this y plus 2, okay, that's what gave us this one here. Then in order to get rid of that, I want y all by itself, so that means I'm going to divide both sides by n plus 4, so I can get rid of this portion here. Those two will cancel out, leaving me just a y plus 2. Okay, and then I'm ended up with 5 over n plus 4. All right, so it's going to take some practice on these. If you need to, go back in and see if you can try them again, work through those problems. Well, that concludes this video. If you need to, you can rewatch it, but or check out any of the other ones that I've got that have different problems, but specific ones as well.